Hey, grade 8, let's take a look at this filament bulb. Now, these are pretty common. You see them all around houses, and we use them to supply rooms with light. And in order to get them to work, we first of all need to supply them with some electrical energy. And that electrical energy can either come from the wiring in the house, or if you have maybe a lamp, you might plug one of these into a power point to supply it with electrical energy. And we know that the objective of having one of these, the reason why we buy one of these is to give us light, okay, light energy. So there's a transformation of electrical energy into light energy in this filament bulb, and that's what we want it to do. We want it to produce light energy. However, we also get heat energy produced. So if you were to leave this light bulb on for a little while and then touch the surface, which I wouldn't recommend, but theoretically if you were to touch the surface of this bulb, you'd notice it's very hot. Or you could even probably hold your hand close to the bulb and you'd notice that heat was being produced from the bulb. So we might say that while the light energy is what we want it to do, we want the bulb to produce light, you might say that the heat energy is actually wasted energy. We don't really want the bulb to produce heat. It doesn't really serve a purpose for us. And so what we're able to do is we're able to think about the efficiency of this bulb. And what that means is, when I use the word efficiency, we're able to think how much of this electrical energy is actually converted into light energy and how much of it is actually wasted as heat. What's the efficiency in the transformation from electrical energy into light energy? And let's have a look at the equation we need to think about that. So the efficiency, it's always measured in a percentage, or at least in our first example, it'll be measured in a percentage. It can actually sometimes also be measured in decimals if you know how to convert from a percentage to a decimal. Efficiency of an object, whether it be our light bulb or something else, is equal to useful energy divided by input energy multiplied by 100. And so let's take a look at an example. Example 1 here says, if you have a filament bulb and it is supplied with 100 joules of electrical energy, which it converts to 25 joules of light energy, how much energy is wasted? Okay, well, let's first of all think about our little light bulb. And this guy here is producing light. And 100 joules of energy is being put into our light bulb, but only 25 joules is being produced as light energy. And you might think to yourself, okay, well, where's the rest of it going? Well, we can probably work out by going 100 joules minus 25 joules, that there would be 75 joules of wasted energy. Whoops. And that wasted energy might be in the form of heat or something else. So that actually answers the part A here. It says how much energy is wasted. Well, we can say, well, 75 joules of energy is wasted. In what form is the energy wasted? Okay, well, this question is asked us to work out, well, maybe what type of wasted energy might there be? Well, if you think back to our little simulation before, we might say that the type of energy could be heat energy, perhaps. And you could also probably say maybe even a little bit of sound energy might be in there as well. The buzzing of the light bulb might also be considered a little bit of wasted energy. Part C here says, what is the efficiency of the bulb? So this is where this equation here becomes useful. This equation solves for efficiency, and the question here is asking us, what is the efficiency of the bulb? So let's do that. So efficiency which is percentage, is equal to useful energy divided by input energy times 100. So let me just scroll down here a little bit. Oops. Now let's solve for this. So the useful energy is equal to 25 joules. So that's the energy that I want my light bulb to have. The input energy, so the total input energy was 100 joules. Multiplied by 100 is equal to, so I go over my calculator, 25 divided by 100 times 100 is 25. And my answer is going to be in percent, because the equation says that efficiency is measured in percentages. So my useful energy, so the amount of energy that the light bulb produces that I want it to produce, 25 joules, is it goes on the top in the numerator, and the 100 joules is my total input energy. So this is my input energy over here, the amount of energy I initially supplied to my light bulb. So I divided 25 by 100, times it by 100, and my answer is 25%. And I'll underline my answer there so we can all see that that is my answer. Let's take a look at some of the features of my working. I've got my equation fully written out. I've got my equal signs all lined up. I've got my units and my answer, and I've underlined my answer. Let's scroll down and have a look at a different example. So this one here talks about a kettle. So it says a kettle takes in 2000 joules of energy per second. It transfers 1500 joules as useful heat energy, and 500 joules is wasted as sound energy. Calculate the efficiency of the kettle. Okay, let's have a go at this one. So this one's also asking us to calculate efficiency, so let's write in the equation. Okay, so efficiency is equal to useful energy divided by input energy multiplied by 100. It says a kettle takes in 2000 joules of energy per second. So by taking in, that's going to be its input energy. It transfers 1500 joules as useful heat energy, and 500 joules is wasted as sound energy. So this number right here, 1500, is our useful energy, and our input energy is 2000 joules multiplied by 100. So we can see here this 500 joules of energy. While it's nice to know that's the wasted energy, it's not actually used in any of our working. Let's go over to our calculator and solve. 1500 divided by 2000 times 100. And there's our answer, 75. So 75, and we know that efficiency is measured in percentages, so it's going to be 75%, and we underline our answer. And let's have a bit of a look at how I've done this. I've got my equal signs all lined up, or as best as I can. I've got my equation fully written out. I've got my working. I've got my answer with my units, percentages, and I've underlined my answer. And there we go. So there's our second one done. And note for this example here, I didn't need to do up a little diagram. I didn't need to draw the kettle and have my input energy or any of that like I did up in this top example. I didn't need to draw all this in. That wasn't of much use to me in this question. All right, let's go have a look at a third example. So example 3 says, calculate the efficiency of a TV which takes in 5000 joules of energy per second and transfers 1000 joules as useful light energy and 1500 joules as useful sound energy. The remaining 2500 joules is wasted as heat energy. Express your answer as a decimal and not a percentage. Okay, excellent. All right, let's get into this. So again, this is asking us to calculate the efficiency. So what's efficiency? Efficiency in percent is equal to useful energy divided by input energy multiplied by 100. Now note that we've always thought about efficiency as being a percentage. Well, we're not going to think about it like that, are we? So what we're going to do is we're going to go and rub that out. Efficiency will be measured as a decimal. And so to turn this into a decimal, we don't have to also times by 100. Whoops, where is it? So there's my efficiency as a decimal. This is going to come out as a decimal. I don't have to multiply it by 100. So let's have a look at this. So efficiency, therefore, is equal to our useful energy. All right, so we've got in our question 1,000 joules as useful light energy and 1,500 joules as useful sound energy. So our useful energy will be 1,000 joules plus 1,500 joules. And all of that is divided by our input energy, which is 5,000 joules. So what do you notice about this 2,500 joules, which it says is wasted as heat energy? It doesn't actually belong in our working, does it? Because our equation, efficiency, our useful energy divided by input energy, there's no mention there of anything about wasted energy. And now we can go to our calculator and we can solve. So let's do the top line first. Let's go 1,000 plus 1,500 equals 2,500 divided by 5,000. There we go. Our answer is equal to 0.5. Now, why have I left my answer as 0.5? Because the question says express your answer as a decimal and not as a percentage. If I wanted to, so we've finished the question. This is everything they've asked us to do. If this question said, let's have your answer as a percentage, let's go back to my calculator. I could have multiplied this by 100 and it would have been equal to 50. So it wouldn't have been 0.5 as a decimal, it would have been 50% as a percentage. And so that's why up here in my equation I removed the multiplied by 100, because that stopped me from converting this decimal into a percentage.